everybody, let's get started on problem number 8. We just finished up problem number 7. Let's look at 8a. This is solved by substitution. However, they do give you a nice graph here that kind of give you a little indicator of what to expect in your answers. So don't necessarily just go by the graph. You still need to show your work of solving by substitution. This will just kind of help check our work at the end. So notice here it says y is equal to 2x squared minus 4x minus 1. This also says y is equal to negative 2x plus 3. So when we say solve by substitution, we really say isolate one of your variables. And in this case, y has already been isolated for us. And then substitute that into your other equation. And so essentially that's going to look like 2x squared minus 4x minus 1 now equals negative 2x plus 3. Since the y is equivalent to that. Now notice we have a quadratic here to solve, and so we're going to move our components over, add 2x and subtract 3, and that gets us the quadratic 2x squared minus 2x minus 4 equals 0. Notice they have a GCF, so I'm going to factor out a 2. I get x squared minus x minus 2 equals 0. I'm going to continue factoring this. That would give me x plus 1. And x minus 2 equals 0, and so I get x equals negative 1 and x equals 2. Now remember, this is just 50% of my answer. Again, notice at our little helpful hint here, it obviously intersects at 2 places, and so we're after 2 sets of ordered pair. So this is what I mean. Right now we have negative 1 comma a mystery. We're looking for the y value that goes with that, and then we also have 2 comma a mystery. We're looking for the y that goes with that. So when that happens, you want to do what we call back sub, which is in one of your original equations. It doesn't matter which one. I'm going to use this guy. Every place I have an x, I'm going to put in a negative 1. So y equals negative 2 times negative 1 plus 3. Y equals, that would give me positive 2 plus 3. So when x is negative 1, my y is 5. So let's see if that's true. Negative 1, 2, 4, 5. Sure enough, that is one of my intersection points. And then now we'll do the same thing for here. Y equals negative 2x plus 3. I'm still going to use that second equation. Y equals negative 2 times 2 plus 3. Y equals negative 4 plus 3, which would give me negative 1. Again, we can confirm that with our little image here. We have 1, 2, down negative 1, and in fact that is. So this is a consistent system that meets at 2 places. I'll do B in a separate video since this was a little bit more complicated.